Okay, that one is if it is in series. What happens if you are having a parallel? Okay, this parallel is especially very useful if you want to tackle a flooding. When you have a flooding, you do not want to push it very high. What do you want? You want to make a fountain? No. Right, you just want to deliver the water from this location to that location as fast as possible. Right, so you put it in parallel. When you put it in parallel, then this is the combined capacity. The free delivery is very high, but the shut-off head is the strongest pump. The strongest pump here is pump 3, so you can see the pump 3 is the maximum shut-off head that you can have. Right? Same story when you have a very heavy downpour, the heavy rain, you need to deliver all the water from the tunnel outside, then you use all the pump. So you can drive until there. But if you don't need it, you just have it. So it depends on your system curve. Right? Still remember your system curve? If your system curve is very like that, so you use that. If your system curve is like that, first step, so you need to make it in series, depending upon your system curve. So later on, when you design a pump for your company, either you are working with Halliburton or Schlumberger or Petronas, sometimes you need to deliver from this point to that point. That's why I have shared with you, right? The question that I got when I got interview from Schlumberger is to design a pumping system from the offshore platform to the onshore terminal, right? That's it. The question is like that. I have an offshore platform. It's producing 5,000 barrels per day over there, and I just want to export it. Simple as that. Then you calculate the pumping power. Okay. You have to roughly know, right? You cannot have a single pump, a very big single pump. You cannot. Because of course, in platform like that, you cannot have very big component, a single component very big. You have to have a multiple. If something broken, then you can replace or you can have some backup. Right? So that's the case. Let's see one problem. Okay, this is your problem. Luckily, it is example. If I just put problem, you solve it, or it is your problem, not my problem. I think I should put that later on. Warning student, this is your problem, not my problem. Right? Okay, so you have those two pumps. Okay, now, if you are observant, by now you know that if you have a performance curve of a pump, this one will always be negative. But when you are looking at the system characteristic curve, it will always be positive. Okay, if you are observant. By now you should know that this one will be negative for a pump, for a system it is positive. Okay, so you have these two pumps. Now if you put it in series, the shut-off head will be this plus that. Okay, this plus that. But the maximum Q you need to calculate. When the head is equal to 0. Right? Free delivery is here when head is equal to 0. So you can see pump 1 is 10 liter per minute and pump 2 is 14. So you can see the maximum free delivery is 14. It is not 24. Okay? But if you put it in parallel, then this is your 24. But the cut-off head will be 9.25. It's supposed to be in tutorial, but this one is the one that will give you a headache. There is some logic that will not be played here. You want me to explain to you or you want to do it yourself?
Explain.
Why don't you try it yourself first? Okay, so ladies and gentlemen, coming back, if you want to get your Q, what will you do? Yes, you need to find the operating point or the Q operating or Q duty. So if you are given those two, how do you get the Q? HS, HP. Right? So you get 6 minus 6Q squared over 400 become? Let it be like that lah. 6 Q over 400 square is equal to 2 plus 1.25 times 10 to the power of minus 4Q squared. So from here you can calculate your Q is equal to something. Once you get your Q, you can calculate either HS or HP. These two should be same. Okay, so you do that, you will get your HP and HS. In this case, it will be 158.89 liter per second. Remember the unit, the unit is liter per second, but since both of them are in liter per second, you don't have to worry. Then you can calculate the HP. Now, if you are having two pumps in series, what will happen? You have two pumps in series, which means you double the HP, right? So when you double the HP, it will become 12, 1 minus Q over 400 Understand why it become 12? Double the HP. Why HP? Because HP is your pressure. Okay, done. How about the parallel? Higher Q. How do you make it higher Q? Higher Q, higher Q. This is the most interesting part actually. Usually students will complain to me about it. So I'm waiting for that. Huh? Yeah, higher Q. Q divided by 4. How the pump characteristic will be when you put it in parallel? This one is